Good morning, my dear students. 8th standard subject Science, chapter number 5 Inside the Atom. I hope you all have understood the topic which we have discussed in last lecture. Now, today we are going to discuss about Bohrs stable orbit atomic model. In the year 1913, Danish scientist Niels Bohr explained the stability of atom by putting forth stable orbit atomic model. The important postulates of Bohr's atomic model are as follows. First of all, I am reading all this part, then only I'll explain you the things which are given in detail. So, very first is the electrons revolving around the atomic nucleus lie in the concentric circular orbits at certain distance from the nucleus. Energy of an electron is constant while it is in a particular orbit. When an electron jumps from an inner orbit to an outer orbit, it absorbs energy equal to the difference of its energy level. When it jumps from an outer orbit to inner orbit, it emits energy equal to the difference of its energy level. As we all know, the atomic structure of an element is this way. This is nucleus, first orbit, second orbit. In the nucleus, presence of proton and neutron is there, and in the orbit, electrons are revolving around it. Okay, this way electrons are revolving around it. So, the first point is the electrons revolving around the atomic nucleus lie in the concentric circular orbits at certain distance from the nucleus. That means they are revolving around the nucleus. Likewise, how the planets are revolving around the sun. Next point is energy of an electron is constant while it is in a particular orbit. When electrons are revolving around the nucleus, means this is nucleus. I am telling you again, this is nucleus, and electron revolving with this orbit, first orbit, second orbit. As you all have seen in the video part of last lecture, how electrons are revolving around the nucleus. Okay, so this is your first orbit, this is second orbit, and so on. Okay, so energy of an electron is constant while it is in a particular orbit. When electron is revolving around this particular orbit, then the energy of this electron is constant. If this electron will jump from this orbit to another orbit, at that time the energy will be changed. But here our sentence is, when the electron is revolving around a particular orbit, the energy will be same. Okay, now next point is, when an electron jumps from an inner orbit to an outer orbit, it absorbs energy equal to the difference of its energy level. And when it jumps from an outer orbit to an inner orbit, it emits energy equal to the difference of energy level. What is the meaning of this thing? Obviously, if you are talking about your nucleus and energy levels of the electron, then this is the nucleus and electrons which are revolving around the nucleus. Okay, if the electron which is revolving around the nucleus in the first orbit, when it is jumping from this orbit to another orbit, that means I can say over here that inner orbit to an outer orbit. When this electron is jumping from inner orbit to outer orbit, it absorbs energy equal to the difference of its energy level. That means suppose a specific energy level over here on this inside inner level of this electron, when it is jumping from inner to outer orbit, it is absorbing the energy which is the energy of this at outer orbit. So and it will equalize the energy, so we can say that it is equal to the difference of its energy level. And when it is coming back to the its original orbit, I can say this, when it is jumping from inner orbit to outer orbit, and again when it is coming back like outer orbit to inner orbit, when the electron is coming back to the outer orbit to the inner orbit, we can say that when it jumps from outer orbit to inner orbit, it emits energy equal to the difference of its energy level. So obviously when it is going from inner to outer orbit, that time it is absorbing energy for the equal to the equal level of the energy of the outer orbit. Now when it is coming back to its original orbit, then it is whatever the energy does not require that electron, it will emit the energy. So this is happening over here with this in this statement. Okay, so here is the model, Bohrs stable atomic model. Actually what happened when Rutherford explained about this electron structure, at that time he did not explain the he did not explain the energy level and the atomic structure of the atomic model. So whatever the drawbacks comes in the Rutherford's model, all gets clearized with Bohrs stable orbit model. Okay, so here is the Bohrs stable atomic model. So you can observe here, this is red coloring, you can observe here, that is your nucleus. In the nucleus, I already told you, proton and neutrons are there, and in the orbit electrons are revolving in it. So if you have not understanding this thing, so please go in previous lecture. I have shown you in gold coil experiment how electrons getting revolving around the nucleus. You can observe over there. Okay, so here is the theory part. Bohrs stable orbit atomic model. You can observe here the very first shell, which is known as K, L, M, N, and so on. The very first shell is number 1, number 2, number 3, and number 4. We can give the name K, L, M, N, and so on. And in the nucleus, positive charge are present in the nucleus. Okay, so some more atomic models were put forth after Bohrs atomic model. Atomic structure was studied at depth with advent of new branch of science is called as quantum mechanics. There is a branch of science which we are studying in physics, that is the quantum mechanics, and in this quantum mechanics we are going to study about all this atomic structure of the in detail. With all those some well accepted fundamental principles of atomic structure as follows. As per this construction quantum mechanics, we are going to study in detail about atomic structure. So here is the atomic structure. An atom is formed from nucleus and extranuclear part. An atom is formed from nucleus and extranuclear part. And these contain 3 types of subatomic particles. Subatomic particles are nucleus. Very first is nucleus. The atomic nucleus is positively charged. Almost entire mass of the atom is concentrated in the nucleus. Obviously anything, if you are going to search anything, obviously its mass will be in its center. So it is happening with atom also. The overall mass is concentrated in the nucleus only. The nucleus contains 2 types of subatomic particles, together called nucleons. In the nucleus there are 2 subatomic particles, and both we can name it as nucleons. And the nucleons are protons and neutrons. These are the 2 types of nucleons. 2 types of nucleons are protons and neutrons. The very first part is proton. Proton is positively charged subatomic particle in atomic nucleus. The positive charge on the nucleus due to proton in it. proton represented by the symbol P, small p. For proton, there is a symbol small p. Each proton carries a positive charge, which is 1 electron. We can say it as plus 1 electron because it is positive charge. And if you want to convert this 1 electron to coulomb, so the conversion is 1.6 into 10 to the power of minus 19. This is the conversion of 1 electron. If you are going to convert this 1 electron to coulomb, then the conversion is 1.6 into 10 to the power of minus 19 coulomb. Because of this is charge, we can measure in the coulomb. When total positive charge in the nucleus is expressed in unit E, its magnitude equal to number of proton in the nucleus. Whatever the number of proton in the nucleus, that is equal, we can equalize the magnitude. Suppose number of protons are 20, then we can say 20 electron. The number of protons in the nucleus atom is the atomic number of that element, and it is denoted by the Z. It is denoted by the capital Z. Means we can say that like mass of one proton is approximately 1 unit, or we can say it as 1 dalton. So there is a conversion of unit to gram also. 1 unit means 1.66 into 10 to the power of minus 27 gram. If you want to measure that proton in unit, you can convert it into gram also. Whatever it is, suppose 2 unit is there, so you can multiply by 2 multiply 1.66 into 10 to the power of minus 27. If 3 unit is there, then 3 multiply by 1.66 into 10 to the power of minus 27 gram. Okay, the mass of one hydrogen atom is also approximately 1 unit. If you want to measure the mass of hydrogen atom, it will be 1 unit only, approximately 1 unit. Now next is neutron. It is represented by small m. Proton was represented by small p. Okay, neutron is an electrically neutral subatomic particle, is denoted by symbol m. The number of neutron in the nucleus denoted the symbol capital N. If you want to show the number of neutrons, you can show with the capital N. Atomic nucleus, all elements except hydrogen with atomic mass 1 U unit contains neutron. That means we can say that hydrogen, except hydrogen is hydrogen with atomic mass is 1 unit contains neutrons. The mass of neutron is approximately 1 unit, which is almost equal to that of proton. If you consider 1 unit of neutron, mass of neutron, then it is almost equal to the whatever proton you are considering, that much will be a neutron. Okay, so whatever the measurement you will get a proton, that much neutron will be there. Now next is, what is extranuclear part? The extranuclear part in the atomic structure includes electrons revolving around the nucleus and empty space between the nucleus and the electron. Suppose if I will show the electronic structure of this atom, then I can see this is nucleus. In this nucleus, proton and neutron are there, and electrons revolving around it. What about extranuclear part? Extranuclear part in the atomic structure includes the electrons revolving around the nucleus and the empty space in between nucleus. Empty space between the nucleus and electron. Whatever the empty space is there in the nucleus and electron, that is extranuclear part. Okay. Next is electron. Electron is represented by small e with this minus sign. So we can say electron is a negative charge subatomic particle, and it is denoted by symbol E minus, this way. Okay, this is the notification of electron. Each electron carries 1 unit of negative charge. Whatever the number of electrons revolving around the suns, around that, each electron carries 1 unit electron charge. That means I can write minus 1 electron. Mass of an electron is 1800 times less than that of hydrogen atom. Whatever the mass of hydrogen is there, whatever the mass of hydrogen is there, less than that of 1800 times, 1800 times less. Whatever the mass of hydrogen, whatever the mass of hydrogen, 1800 times less than that will be the mass of electron. So you can imagine how much small it is. Okay. Therefore, the mass of an electron can be treated as a negligible. Electron in the extranuclear part revolve in this discrete orbit around the nucleus, the orbit being three-dimensional in nature. A term shell is used instead of term orbit. If you are using, as I used to say the word orbit, first orbit, second orbit. Now after giving name K, L, M, N, so we can say this K shell, M shell, N shell. Okay, so the name is shell used to instead of the orbit. The energy of an electron is determined by the shell which is it present. The number of electron in the extranuclear part is equal to the number of proton in the nucleus. Whatever the number of electron in the extranuclear part is equals to the number of proton in the nucleus. Therefore, electrical charges are balanced and the atom is electrically neutral. Obviously, if you are writing +2, -2, then your answer is neutral. Okay, so in the similar manner, if you are saying electrons are revolving around the orbit or shell, we can say that. So it may be it has a negative charge. So it does not like that, because whatever the number of electrons are there, the same number of protons are also there. Electron carries negative charge and proton carries a positive charge. So hence it becomes neutral. As we discussed about theory, you can give the answers of these questions. Please read the theory carefully and think the answer for the same. So use your brain power. If you have any doubt related to this question, ask me. Anyways, I'm going to tell you the answers of this also, because I already explained all these concepts. So just think about that. Okay. The mass of an electron being negligible, therefore the mass of an atom is mainly due to the protons and neutrons in its nucleus. Obviously, because why the mass of electron being negligible? Because the mass of electron is 1800 times less than that of hydrogen's mass. So you can imagine how it is negligible. So we can say that therefore the mass of an atom is mainly due to the protons and neutrons, because protons and neutrons present in its nucleus, and hence whatever the concentration is there, it comes from its nucleus. So we can find out the mass of an atom with the help of this nucleus. Okay. The total number of protons and neutrons in an atom is the atomic mass number of that element. Whatever the total number of proton and neutron, it gives us atomic mass of that element. Whatever the protons and neutrons present in the nucleus, it gives the atomic mass of the element. Whatever element you are using, that is we can measure the atomic mass of the element with the help of protons and neutrons. Number of protons and neutrons. Okay. The convention denote atomic symbol. What is the atomic symbol for us? So atomic symbol is, the mass number is denoted by symbol A. Atomic number and mass number are together shown in follow. We can write this way. Whatever your symbol, suppose hydrogen is there and A and Z. What is A? A is mass number. A is mass number and Z is mass number. So here is the symbol. For example, the conventional symbol of carbon, where you can observe, means 12C6, means that the atomic number, that is the proton number of carbon is 6, the proton number of carbon is 6, and mass number of carbon is 12. So this is the example how to write this AZ symbol. Okay, from this is also we learn the nucleus of carbon content 12 6, that is 6 neutrons. 6 neutrons. In this example, atomic number and the masses are given. You have to write in the formula, which is A, whatever your symbol, and Z, you have to submit over there. Likewise, I'll give you the solution for one. Now remaining you have to solve. Suppose I'm solving this one. Atomic number and mass number is given. Atomic number is 12 and mass number is 24. So how to write this? It will be 24 magnesium and 12. So remaining you try it out. Point number 1, 2, 3, 4, 5. Please write it in your book. Now next is distribution of electron. As per Bohrs atomic model, electrons revolve in stable shells. These shells have definite energy. The shell nearest to the nucleus is called first shell. Whatever the shell, it is nearest to nucleus, that is first shell. The next shell is called second shell. A symbol N is used to ordinal number of shell. Suppose here in this diagram you can observe here, which is this one. If I'm gonna write, this is first, second, third, fourth, and so on, 5, 6, and so on. So to represent this shell, I can write N, number of shell. N gives us the representation of number of shell. So a symbol N is used for the ordinal number of shell. The shells are referred to by the symbols K, L, M, N, and so on. Corresponding ordinal numbers 1, 2, 3, 4. So that is why we can write number of shells. The maximum number of electron a shell can contain obtained by a formula 2 raised to the power of n square. As the magnitude of n increases, the energy of electron in that shell will increases. It means this formula gives us the presence of electrons in the shell. Likewise, if I'm gonna draw the orbital structure, then this is your nucleus, this is first orbit, this is second orbit, this is third orbit, and so on. Now in which orbit how many electrons are revolving in it? So this formula gives us the number of electrons. If you put a first shell, like number 1 shell, so you have to put over here instead of n 1. So it will be 1 square 1, and 1 multiplied by 2 is 2. So in the first orbit 2 electrons are there. Now with the second shell, how many electrons should be there in the second shell? So substitute instead of this n 2. 2 square will be 4, and 4 multiplied by this 2 will be 8. So that means I can write with the second orbit number of electrons are 8. In the second orbit number of electrons are 8. Now what about third orbit? Suppose this is your nucleus, first orbit, third orbit, second orbit, and third orbit. So third means instead of this n you can substitute 3. 3 square 9, and 9 multiplied by this 2 will be 18. So in the third orbit how many electrons are there? 18 electrons are there. So in this way we can write 2, 8, 18, and so on. To find this so on, that means we need a general formula for the same, and the general formula for the same is 2n square. Okay, so here is the table for the same, which I have explained. you can write down over here in which cell how many number of electrons revolving with it. Okay, suppose I am substituting, this calculation will be 2. If this is second shell, then 2 multiplied by 2 square, and 2 square multiplied by 4 means 8. You can substitute over here 3. 2 multiplied by 3 square, and 3 square means 9 multiplied by 2 is 9 to the 18. If fourth shell is there, then 2 multiplied by 4 square, and 4 square is 16. 16 multiplied by 2 is 32. So this way we can solve this structural formula. Okay, 2n square is the structural formula. So please write it down, complete this table also in your book. Whatever I am telling you to write, to solve, to complete, so please do this kind of questions solve in your book. You will get an idea. So if you are not understanding, just WhatsApp me, I'll clear your doubt. Okay.